Friends, today we are going to take very important theorem. This is one of the very important property of this year. This is called as basic proportionality theorem. So what is this exactly? See here, the statement of that one. Listen carefully, this is very important one. In a triangle, if a line which is parallel to one of the side of triangle and it intersects remaining two sides in two distinct points, then the line divides remaining two sides in equal ratio. See here, what is this? First of all, we are going to draw a triangle here. Observe here. This is a triangle. Okay? In this triangle, suppose we will take names A, B, C is a triangle. In this triangle, line L, we will draw line L which is parallel to this side BC, which is the side of triangle ABC, and it intersects remaining two sides AB at P and AC at Q. This is the given information. Then this line divides these two sides in equal ratio, means what? AP upon PP equal to AQ upon QC. Understand? This is very important. Second part, in triangle ABC, line L, or you may write line PQ also. This line PQ is parallel to side BC. Okay? It divides or it intersects AB at P and AC at Q. That one we can write like A dash, P dash, B, and this side A dash, Q dash, C. This much is the part which is given to us. So from this information, we are going to prove. What we have to prove? Writing to prove part. Listen very carefully. This AP upon PB and AQ upon QC, this ratio is same. That one we have to prove here. See here. AP upon PB is equal to AQ upon QC, which we have to prove. See here. In this part, just see here now, we need AP upon PB. If you observe here, AP upon PB, when we can get this ratio AP upon PB? Because we have to prove this AP and PB and AQ and QC, these two are, we have to prove, they are same. Now, we need AP upon PB. How can we get? For that, we are going to make some construction. What is that construction? We will join this PC and this QB. From that construction, what we can get? First of all, we will write that construction part. See here, construction. What is the construction? Join PC and QB. After joining this one, what we can get? See here, I am going to make some parts of this figure. First of all, see that this is the one part of the triangle of this given figure. Tell me the name of the triangle. AQB. Is it correct? Here, that PQ is also be there. Now the next part we need here APC, this side. APC. This is again very important. Here also this PQ will be there. Here in this figure also be there. After that we need one more, which is, see here. Yes, if you observe that one very carefully. I'll write the names also. What is the names? Here P, Q, I think this side B, and it is C. Observe. In these three parts of the given figure, what you can think here? We need AP upon PB. When we can get this one? If you observe. First of all, in these two figures, I will take some explanation about this figure. See here. In this figure, suppose here it is one segment. Write the names, some names here like P, Q, R, and here it is S. Observe here. Tell me how many triangles are there in this figure? Either 2 or 3? there are three triangles. Yes, PQS, PSR and this full PQR. In all the three triangles, there is one common part is there. What is the common part? This P is the common vertex. From that vertex, if you draw one altitude, that will be the common to all the three triangles. See here, this is the height of triangle PQS. Again, this is the same height for triangle PSR and triangle PQR as well. This PM is the common height of all the three triangles. Just by turn, we will get this figure. So in this figure is also, if you draw from Q one altitude, so that altitude will be the common for all the three triangles. Here also APQ, PBQ and this full ABQ. All the three triangles have the same altitude. Means all these three triangles having same height. Similarly, here also, if we draw, again here also one altitude. So this will be the common altitude or height of all the three triangles this side also. Okay? So we need AP upon PB. Tell me what these are, AP and PB? They are respective bases of corresponding triangles. So tell me now, AP is a base of which triangle? APQ. And this is a PB, is again base of one triangle, that is PBQ. So now we are going to write these two triangles' areas. Their ratio is AP upon PB because of they have same height. Okay? Similarly, here also. So from that information, we can get this one. Now, the next part, again one more information also we need here. See, because of PQ and here it is one BC. Yes, look here. These two are parallel to each other. Suppose they are parallel to each other. If you observe here, whenever these two lines are parallel, here the two triangles are there. These are the two triangles which are enclosed in these two parallel lines. So, what we can consider here? They have same height. Okay? Like in previous examples we already studied, whenever here it is, the two lines are parallel, then their distance between these two parallel lines is always same. So now observe here, PQB, this is the first triangle in which PQ is common base and this will be the height. Similarly, in this triangle PQC, that is also one triangle. Yes. So this triangle also PQ is their base, common base. At the same time, this will be their height. If you observe here, these two lines are parallel. Therefore, the distance between them is same. Therefore, we can write triangle PQB and PQC. These are the two triangles having same base and same heights. That means we can use the property if the two triangles having same height and same bases, then their areas are equal. So using here the properties, we can prove this BPT, basic proportionality theorem, which is one of the very important one. So first of all, it is very important one. So we need first, see here, area of triangle APQ. Listen very carefully. Upon, we'll take area of triangle PBQ. Yes, tell me what you can write now. They have same heights. That means we can write now AP upon PB. AP upon PB. So tell me the reason here. They have same height. Understand? Similarly, here also. Area of triangle, again this side APQ upon area of triangle PBQ. Their areas also depend upon their corresponding bases. Here it is the base AQ upon QC. Okay, yes, we can write they have same height. Now we are going to prove these two are same. That is our aim. So when we can prove these two are same? If we can prove this side is same, then it is very easy to write or say this side is same. Now to prove these two are same, we have to prove these two are same. If you observe here, just listen very carefully. These two, the ratio of areas, we are going to prove they are same. For that, already they have numerator is same. If you observe here, look here, they have numerator is same. Yes? To prove these two are same, it is enough to prove their denominators are same. First of all, here by mistake PBC, PBQ, for that here we need here PQC we need here, okay? Or you may write PCQ. This is very easy, very important one. PCQ, this side. So now we are going to prove these two are same. Where these two are? Just here. PBQ and PCQ. These two areas we are going to prove they are same. When they become same? Just here. They are in this figure. They have same base and common height or same height. That means their areas are same. So by that property we can say that denominator is same. Already numerator is same. Therefore this side is same. That is why we can say AP upon PB equal to AQ upon QC. This is the way we have to prove this theorem. Okay, now let's write all the proof part stepwise. Let's see here. Yes, now we'll write stepwise the proof of this theorem. See here. Okay, first of all, this is statement number. Okay, now it is statement, and every step we are going to write reason. Why that step? By which property we have to apply? Okay, let's see here. This is step number 1. First of all, we need AP upon PB. Just as we discuss here now, we are going to take the ratio of areas of area of triangle APQ upon area of triangle PQB, or you may write PBQ. Okay, that is equal to AP upon PB. Yes, tell me the reason. AP upon PB. The reason is what? They have same height. Okay, but before that one, we have to write A dash, P dash, B, and write triangles having equal heights. Okay, now similarly for the next step. Again, we need now this side AQ upon QC. For that, we have to choose the triangles APQ and PCQ. So area of triangle APQ upon area triangle PCQ. Okay, and that one is equal to their corresponding bases, which are AQ upon QC. AQ upon QC. Here also we have to write first A dash, Q dash, C, and the same reason here also. Triangles having equal heights. Okay, this is very important part. Now the next part, we are going to prove these two are same. For that, we are going to equate these two ratios. Already they have numerators are same. Now only to prove the denominator, which is area of triangle PBQ and PCQ. Already just we discussed, they are enclosed in two parallel sides. So first mention that one, line PQ is parallel to BC. Where it is? It is in given part. So we'll write first in given part. So using this step, we are going to write these two triangles have same areas. So area triangle PBQ, which is equal to area triangle PCQ. This is from third step, and triangles having same bases and heights. So using this property, we can equate these two triangles have same in areas. Understand? Now, just only by taking very carefully which steps we are going to observe here. This is very important one. See for only first step, second step and this fourth step. What we can conclude? See here, these two are same. Here these are. Already the numerators are same. Means whole fraction becomes now equal. Area triangle APQ upon area triangle PBQ, which is equal to area triangle APQ upon area triangle PCQ. These two become same, and this is from steps number 1, 2 and 4. And now just listen very carefully from fifth and this first and second. Already this side we shown just the same. That means automatically this side becomes same. So that will be the proof. AP upon PB is equal to AQ upon QC. This is from first, second and fifth. This is very important step. So because of that reason, all these steps, listen very carefully. Here the important part is what? This is the third. By parallelness only we can say these two are equal in area. Not only parallel, already they have same common, that is PQ is common. We can say it is a base, and these two are parallel. So these two triangles are enclosed in two parallel lines and they have same base. Therefore, these two triangles are in equal areas. Understand? Remember, not only this theorem is important. Whenever this theorem is not asked in exam, so there are some examples may be asked depend upon this theorem. So students, try to understand. If any doubt, just ask me. That is very important. Okay? Now, after this one, we are going to take its converse also. What is converse? See here, already we know, whenever we are going to discuss in converse part, that converse part is not asked in exam. That proof is not asked, but depend upon that converse property, there are some examples may be asked. What is that? See here. Converse means, as we already studied in 9th standard. Whenever converse is there, this to prove part goes to given and given part comes to proof part. Okay? Means what? The ratio is equal. Okay? And we have to prove they are parallel. Means what will be the theorem? Converse of basic proportionality theorem. What will that statement is what? In a triangle, if a line which divides given to any two sides of a triangle are in same ratio, then the line is parallel to third side, which is exactly converse of this theorem. Okay, let's take that one. Now see here, in the second property, which is basic proportionality theorems converse. See here, that is again one of the very important one. In a triangle, a line which divides any two sides of this triangle in equal ratio. That means now they are given to us. Here it is one line which divides any two sides of a triangle in equal ratio. Then we have to prove this line is parallel to the third side of that triangle. Okay. Similarly, we take here ABC is a triangle. Line PQ is intersects AB at P and AC at Q, such that AP upon PB is equal to AQ upon QC. Now they are given to us. So we have to prove this PQ is parallel to BC. In this part, we don't need to give any kind of proof. Only we have to understand the converse of BPT, They may be used in some examples. So that is enough. I will write only given part and to prove part. Okay, we can prove, but that part is not in our syllabus. Okay, see here. Given part. What will the given part? In triangle ABC, this line which intersects AB at P means we can write A dash, P dash, B, and now here A dash, Q dash, C, such that AP upon PB is equal to AQ upon QC. This is the given part. So we have to prove that the line PQ is parallel to BC. Line PQ is parallel to BC. This part we can prove. In the previous syllabus, the proof is also be there. But now, in this today's syllabus, this proof is not in our syllabus. But we can use this property in examples. Students, try to. How can you use this property in example? Sometimes in a triangle, they're given to us like this way. This one side which intersects the remaining two sides in different points. See here, suppose PQR is a triangle, MN is the intersecting segment. They're given to us, suppose here 4, it is 6. Now that side 2 and this side is 3. Suppose they're given to us. Now we are going to check whether this MN is parallel to QR or not. So at that time we are going to use this property. How we can use? First of all, we'll take the ratio of one part only, like PM upon MQ. How much? 4 upon 6. We can reduce by dividing 2. That means 2 upon 3. This is first ratio. Similarly, we take the next side, that is PN upon NR, that is already 2 upon 3, we'll take as a 2. Just observe here, one side is same. Here it is, one side 2 upon 3 is same in both the ratios. That is why we can equate these two. Means PM upon NQ is equal to PN upon NR. This side is same. And whenever this ratio is same, so using this property, we can say this MN is parallel to QR. Like this, we can use this property in example. Understand? So very carefully use these all properties in example. Okay? Hello friends. Now today we are going to use the applications of BPT. That means what? In some properties we are going to apply the property of BPT. Okay? That is the first one, 3 parallel lines and their intercept. What is that? We know 3 parallel lines, and about the intercept also we studied in last year. So now today in this topic the next property is what? 3 parallel lines and their intercept. So what is that property? See here, the ratio of the intercepts made on a transversal by 3 parallel lines is equal to the ratio of the corresponding intercepts made on any other transversal by the same parallel lines. Okay, so now what is that? Look here. First of all, here these are the 3 parallel lines. They are given to us. Okay, here we can write here L, M, and all these 3 lines are parallel to each other. Okay, now here the first we'll draw the first transversal. That is, we'll write first P and then write Q. Okay, see here, this is the transversal number 1, which is P. This transversal intersects all these 3 parallel lines in 3 distinct points. Suppose I'll write here L, M, and N. Okay, here these are the intercepts made here, LM and MN. Remember, LN is also intercept. But now we are going to take only LM and NM. Now here, one more transversal I will draw here. That is Q. Okay. Now here also LMN, and here right here E, F, G. Okay, write any names here. So here also very similar, EF and FG, both these are the intercepts made. Okay, now what is our aim? First of all, what is the given to us? Here line L is parallel to line M is parallel to line N, and transversals P and Q intersects these three parallel lines at L, M, N and E, F, G respectively. Okay, this much is the part which is given to us. So what we have to prove here? We have to prove the ratio, that is Lm upon Mn. This ratio which is exactly equal to the ratio of EF and FG. That is our aim. Okay, first of all we'll write given and to prove part. See here, what is given to us here? Line L parallel to line M parallel to line N. Okay, now transversals P and Q intersects at L, M, N and E, F, G respectively. This much part is given to us. So from that given information, what we are going to prove? We are going to prove here to prove the ratio, just what I told you. Lm upon Mn is equal to EF upon Fg. Okay friends, now just try to discuss how we can prove these two are same. How we can prove here? For that we are going to make some construction. What is that? Join LG. You may draw En also, but we will draw one of them. And it intersects line M at, we will write any different name, I will write R. So I will draw, this is the construction. What is construction? Draw LG which intersects line M at R. Okay? So by that construction, here the figure is divided in two triangles. Yes? Where you are observing here? Which of the two triangles here? L and G, and other one L, E, G. Here these are the two triangles. Okay, I will make separate them. Okay, first of all, this is the triangle. Try to observe here, which is what? L, N, G. And one more triangle is here. This is the one more triangle. Okay, what is the name of that one? L, E, G. Observe here. This is, in this triangle MR is there, and in this triangle RF is there. Okay. Now just try to observe here. Because of all the three lines are parallel, we can write this much part. MR is parallel to NG, and here in this triangle RF is parallel to LE also. Yes. Now wherever that in a triangle, if the line is parallel to one of the side of the triangle, then we can apply BPT. Okay, that much is the very, very important one. So now we can apply that BPT here. So look here, in triangle LNG, this MR is parallel to NG. That means just in BPT, what we learn here? This LM upon MN, which is equal to LR is equal to RG. This is the first part. Very similar in the same triangle in LEG. In this triangle also we can apply the same property, which is BPT. So here RF is parallel to LE. Because of that reason, LR upon RG is equal to EF upon FG. Now just observe here. In this side also LR upon RG, and here also LR upon RG. So by equating these two, we can get LM upon MN, which is equal to EF upon FG. That is only we have to prove. Understand? Let's start. See here. This is very, very important one. Statement number. Statement. Reason. Without forgetting, every time try to write reasons for each step. Okay? The first one. First of all, we'll write the given part, which is all the three lines are parallel. So look here, line L parallel to line M parallel to line N. This is the given part. Okay? Which is we have to apply this one in these two triangles. So first of all, in triangle. In which triangle? LNG. Okay. Now apply here. So we can write here MR is parallel to NG in this triangle. This is MR which is parallel to NG. So this is from 1 we can write. Yes. After that we can apply now BPT. LM upon MN is equal to LR upon RG. Understand? This is from 2 and BPT. Okay? This is the first part. Very similar in this triangle also we can apply. And in triangle LEG. Apply here also. RF is parallel to LE. Okay, this is also given to us. Apply here also BPT. LR upon RG. LR upon RG is equal to EF upon FG. Okay, this is again from 4 and BPT. Now try to observe here. We have to observe here. See, LR upon RG and here also LR upon RG. Because of these two steps, we can equate third and from fifth. Yes, observe here. That will be our proof. Therefore, LM upon MN is equal to EF upon FG. This is we can write from 3 and 5. Yes. Try to observe here, which is very important one again, and we are going to apply this one in examples so many times. Just try to observe here. Okay? Understand?